All right, let's talk about a challenge that trips up a lot of teams. You need to control a process, you need real insight, but your data, well, it's trickling in one piece at a time. What do you do? The answer is a seriously powerful tool called the Individuals and Moving Range Chart, or the IMR chart.
I mean, really think about that. What do you do when you can't just go grab a big sample? Maybe each measurement costs a fortune, or maybe it takes an entire month to even get one data point. This isn't a textbook problem, this is a fundamental business reality. And knowing how to solve it is what we're going to tackle right now.
Okay, here's our game plan for this briefing. We're going to start by really defining that scarce data challenge. Then I'll introduce you to the IM chart, which is our solution. We'll actually build one, step by step, so you can see how it works. We'll talk strategy, when to use this chart versus others. We'll see how it plugs into a real project, and then we'll wrap up with the key things you need to know for your career.
So why do we even need a special chart for this? Well, because a lot of the classic statistical process control tools, they assume you have subgroups, these nice little batches of data you can collect all at once. But in the real world, that's a luxury we just don't always have.
And these situations are everywhere once you start looking. If your line only produces one highly complex engine per day, you've got scarce data. If testing your product literally means you have to destroy it, you definitely have scarce data. Same goes for those pricey lab tests, chemical processes that produce a single batch, or even things like monthly financial reports. In every single one of these cases, waiting around to build a big sample isn't just slow, it's often completely impossible.
And this is exactly where the IMR chart comes in. It was literally designed for these scenarios. It's a way to monitor and control your process using just one observation at a time. It's a game changer.
So what is it really? At its heart, the IMR chart is a duo. It's a set of two charts that work together to give you a complete, crystal-clear picture of your process stability, even when your subgroup size is just one. It's elegant and it's incredibly powerful.
Now, this is the crucial point. You need both charts. They're like two sides of the same coin. The I chart, or the individuals chart, that's on the left. It plots each data point. It's telling you, hey, is my process average shifting up or down? Then you have the MR chart, the moving range chart, on the right. That one plots the difference, the jump between consecutive points. It asks a different question. Is my process consistency changing? Is it getting more erratic? Having one without the other is like flying with one eye closed. You're missing the whole picture.
All right, enough theory. Let's make this real. We're going to roll up our sleeves and walk through the exact steps to build an IMR chart from scratch. This is how you transform a simple list of numbers into real, actionable intelligence about your process.
We're going to follow this simple four-step process. First, we calculate the moving range to see the variation from point to point. Second, we find the average for our individual values and for those moving ranges to get our center lines. And finally, we'll calculate the upper and lower control limits for both charts. These limits define the guardrails of our process.
To bring this to life, let's use a really practical business case. Imagine you're a sales manager, and you're tracking the monthly miles driven by one of your salespeople. You need to know, is their activity level consistent, or are there weird fluctuations you should be looking into? The IMR chart is the perfect tool for this.
Okay, so here's our raw data. The very first step is to calculate the moving range. All that is the absolute difference between one point and the next. So for month 2, the range is 2. That's just 82 minus 80. For month 3, it's 4, the difference between 82 and 78. See? We just do that all the way down the list.
Now that we have our moving ranges, we can find our baseline, our center of gravity for the process. We need to calculate two different averages, one for the individual distances and one for the moving ranges we just figured out. These are going to become the center lines on our two charts.
The average of the individual data points, what we call X-bar, is 80. Super simple. This tells us that, on average, this salesperson drives 80 miles a month. That becomes the solid center line for our individuals chart. And the average of our moving ranges, or MR bar, is 3.2. So what does this actually mean? It means the typical expected month-to-month variation in their travel is about 3.2 miles. This number becomes the center line for our moving range chart.
Okay, now for the part where the magic happens. Calculating the control limits. These lines define the natural, expected rhythm of the process. Any data point that falls outside these limits is a signal, a flashing red light telling you that something special, something external has happened and you need to investigate.
So, using a standard formula, we calculate an upper control limit of about 88.5. Think of this as the ceiling for normal behavior. Any month where the salesperson drives more than that is statistically weird, and you should probably ask why. And on the flip side, the lower control limit comes out to about 71.5. That's the floor. A month with travel below this is also a signal that something unusual was going on. Together, these two lines define what we call the voice of the process, the range of variation that is totally normal and expected. But wait, we're not done yet. Remember, we also have to know if the consistency of the process is stable. Is the month-to-month variation itself in control? That's what the MR chart limits are for. For our moving range chart, the upper control limit is 10.46. This means any jump between two consecutive months that's greater than about 10.5 miles is a signal that the process variation itself has become unstable. The process has become more erratic.
And the lower control limit for an MR chart like this is always 0. Why? Because you can't have negative variation. It's as simple as that. And with that, we now have the complete boundaries for both our process average and its consistency.
Okay, so now that we've gone deep into the how, let's zoom back out to the strategic level. Because knowing when to use a tool is just as critical as knowing how to build it. The IMR chart isn't a hammer for every nail. It's a precision instrument. This really brings us to a clear, simple decision. When you compare it to another common chart like the X-bar in our chart, the choice is dead simple. It all comes down to one question. What is your subgroup size? If it's 1 and only 1, you use the IMR chart, period. If you can easily grab subgroups of, say, 2 to 10 samples at a time, then the X-bar R chart is your tool. It's about picking the right tool for the job based on the data you actually have. So where does this powerful tool fit into a formal improvement project, like a Six Sigma DMIIC framework? Well, the beauty of it is that it's useful across the entire project lifecycle. In the measure phase, you use it to get your baseline, to understand your starting point. In analyze, any of those points outside the control limits, boom, those are your prime targets for investigation. During the improve phase, you can use it to see if your changes are actually working in near real time. And finally, in the control phase, the IMR chart becomes a permanent part of your dashboard for keeping an eye on the process forever.
All right, let's bring this all home. Understanding the IMR chart is not just some academic exercise. This is core, practical knowledge for anyone who's serious about a career in quality, operations, or process improvement. Frankly, it's a required skill if you want to get certified.
So if you're studying for your green belt or black belt, here's what you absolutely need to lock in. Its core job is to monitor individual data points. It is mandatory knowledge for the big certifications. Its key application, its trigger, is when your subgroup size is 1. And maybe most importantly, remember that the chart is like a smoke alarm. It's brilliant at telling you there's a problem, but it doesn't tell you what caused the fire. That's where your real work begins. And that brings us right to the final and most important question. Now that you know the what, the why, and the how, take a second and think about your own work. That monthly report you pull, that slow production line, that expensive quality test you only run once a day. What process in your world is just waiting for a tool like this to finally bring it under control?